The sheer volume of data involved, once you are tracking data interactions, not just transactions, can stress the capabilities of any individual piece of hardware, which is why Couchbase fundamentally avoids the single points of failure such bottlenecks can represent. Now, SQL Server has evolved into Cadillac-grade software with a powerful symmetric multiprocessing architecture that requires equally Cadillac-grade hardware to scale up to massive application connectivity. Couchbase is different. We're more like a tightly coordinated herd of Toyotas, as few or as many as you need. Our massively parallel processing and storage scale out by node volume or up by individual node capacity, as needed, to support massive application connectivity with far greater operational flexibility. Of course, you might think, well, haven't you paid attention? SQL Server provides availability groups, which is true. You can build and keep multiple fully redundant copies of your database and its storage on hot standby for when something inevitably goes wrong. Again, Couchbase is different. Our single node type handles everything, including storage, which is distributed evenly across your nodes. Our nodes share nothing. Now, life being what it is, something will inevitably go wrong, eventually with some node in any network. Now, when that happens, SQL Server lets you fail over your entire database to one of your hot standby availability nodes. Again, here, Couchbase is different. While SQL Server partitions data by database, we partition by key space, a concept we more commonly refer to as a data bucket, and distribute data across all available nodes. We also let you configure for up to 3 replicas of each record to be distributed across the same nodes, but never on the same as the original. This way, when a node fails, clients are immediately redirected to an activated replica. Then, when the failed node comes back online, replicas are rebuilt and rebalanced as needed. Couchbase nodes are literally identical in their potential and capabilities. At a high level, each node has a cluster manager and exposes 6 services: data, query, index, search, eventing, and analytics, which each provide appropriate caching and storage for their role. Now, beyond the cluster manager, which coordinates the cluster and exposes our comprehensive REST API along with the web UI, the 6 services expose all the functionality of Couchbase. The data service stores data in containers known as buckets, which we'll consider in depth later. It also exposes direct key value access while managing data replication and our MapReduce views functionality. The query service delivers the power of SQL for JSON, which we call Nickel. As you'll see in more detail later in the labs, it plans all queries and helps optimize their performance. The index service maintains global secondary indexes for the system, with in-memory, lock-free maintenance. In the labs, you'll learn how to define and a bit about how to tune these indexes. The search service exposes our full-text search capabilities, which include inverted indexing, faceting, scoring, and more you'd expect from such a system. And all of it without having to pump your data around a network among different servers, just so you can provide natural language queries to your users. This service also manages full-text search index replication for durability. The eventing service lets you define business rules, you could think of them as triggers, and enhance your data with real-time processing without reliance on additional middleware. And our analytics service delivers support for batched queries running in a workload-isolated and distributed manner for the retrospective analyses which you might otherwise, again, need to pump elsewhere in your network with all the additional overhead that requires. As you can see, Couchbase likes keeping your data center simple. So again, we provide a single node type, which makes all our services available. But the services can be scaled and isolated independently. You can stripe everything equally across all nodes, which is the default, and works for small clusters. Then as you grow, you can isolate services to optimize their requirements to preferred hardware, and also scale services independently to meet changing application demands. Over time, you handle growing demand by adding additional nodes tuned for the particular services requiring increased capacity. In short, with Couchbase, you get both maximum simplicity and maximum control across elastically and multidimensionally scalable clusters of commodity hardware. So what have you learned? Couchbase is built on an elastic, multidimensionally scalable, shared nothing architecture. Each node exposes 6 independently scalable services: data for get, set, replication, and MapReduce views; query for nickel query planning and assembly; index for global in-memory secondary indexing; search for natural language queries; eventing for middleware-independent business rules; and analytics for batched retrospective queries. Each of these services can be scaled horizontally across more nodes or vertically on bigger iron. So is it lab time for you yet? If so, grab that lab workbook and start learning how much you already know about nickel. Or stick around for some more videos. Next up, we're going to take a deeper look at how you grab data from Couchbase using our SDKs. Come on back.